Hello everyone, welcome to lecture 5 and in this lecture I will show some template to loading data in Python that can be useful for the assignment 3, which you need to load your data as a part of project. And we show some template in the Numpy and to load data, and then also some templates for the another powerful concept in the Python, which is the pandas. And also I will talk about some different topic that we saw until now, which is the computational complexity. And this is just a simple introduction for this topic, and might be helpful for you to understand the complexity of your algorithms or your code. And also, I will talk about some numerical linear algebra. Let's see first the introduction of the views into Python. A view is a view of an array is another n-dimensional array object that shared the same underlying memory location. So for example, here we have A, which is defined as a Numpy array, and the dimension of the Numpy array is 4 and 5. So if we call a function from the A, which is a.view, and then assign the value of the a.view to the B. So after that, if we check that B is view, B is A, then we get a false. But if B is A is false, means that A and B are not the same object. So we can conclude that A is B return false, right? So we have another attribute, which is a base. So base points to the array from which a view was created. So because we create B from A, so base points to the A for the B here. So because we created B from A, and B is a.view, so base of B point to A, so B dot base is A, means that we should return true. So if we get a view from an array, so the base of the array should be the array that we create, the new array based on the view. So we should just keep in mind that a view is another in the array that share the same exactly underlying memory location. So B is not A, but the base of the B here is A. So we saw lots of function until now, for example, slicing, transpose, reshape, and they all try to create a view if they can, but will silently create a copy if they cannot. So if they can create a view of the array that you are doing for that, for example, you are doing a.reshape, right? So if they can create a view from A and then reshape that, they do. But if they cannot, they just copy the A and try to reshape the array. For example, here, this is a weird example in the Python, and I will show that because I want to mention how we should be careful about using not an ND array or not D-dimensional array in the Python. So here we just create A, which is np.ones, and then the dimension of the A is 4 and 5, and we have two-dimensional array. And as I mentioned, transpose here, transpose is a function that maybe just create a view for doing the transpose of the matrix. So A dot transpose, parentheses, and we assign that to the B. So we check that the B dot base is A or not, and then it's true, means that the transpose create a view of the A and then try to transpose that. So B dot base is pointing to the array that we create B. So the base of the B is A, and which means that B is a view of the A. And after that, we just create B, and we want to reshape B. So we call the function reshape, b.reshape, and we assign this value to the another variable, which is C. So this also create another view. And interestingly, that the C dot base is a returns true. So this means that C also is a view of A. But if we create another reshape based on the B, but with different dimension, here the dimension was 5 and 4, right? So we just create another reshape based for the B, and we call the reshape function b.reshape with different dimension. And this create a copy. And if we call d.base is A, it's return false, right? So this means that based on the dimension that we have here, the Python create a view or create a copy. So, based on, as I mentioned, based on the dimension, the Python decide about this. So we don't know when the Python create a view or create a copy. And this is so tricky, and in most cases, we don't know about that. So, and there are some rules for when a view will be made. However, they are not well documented, and this is just rely on an understanding of the underlying storage. So the model of the moral of the story is that be careful when modifying the content of the array directly. And if you don't know when should use copy or use view, or you don't want to change the value that you have in the first array, try to create a copy. And in most cases, I will suggest that would be a good way to just copy of the metrics that you want to do some operation on that. So let's see an example. What is the difference between the copy and the view? And I have an example here that, for example, here we have, I just need to load the Numpy as an NP and then create a two-dimensional array here and get the transpose of this array that I just created. Now, let's see if that the first, what is the view? So I just print B and A, right? And then I comment all the lines that I have here. And then I just press the run sign. And then you can see the both of these metrics are same, right? So if I change one of elements that I have for A, for example, I want to change the element that I have in this position to 3, right? Then I print A. Also, I print B here, right? So you can see at the first both are two-dimensional array with all elements 1. And then because B is a view of A, if I change the value of one element in the A, which is this one, I change it to 3, the corresponding position in the matrix B also changed to 3. So this means that if you change anything in the A, that would be applied to the B, right? So that's so tricky, and because mostly you don't want to change the numbers that you have in the B, right? So if you don't want to change the value that you have in the B, and you just want to have a copy of the A, you just need to use copy function, right? And then try this. So after that, you can see the corresponding position in the B doesn't change because we just copy the matrix that we have here. So I would suggest that in most cases, just try to use copy function instead of just assigning a matrix to another matrix. And that would be so tricky because sometimes you need to change values in the one matrix, but you don't want to apply to another matrix. So this is a difference between copy and view. And so you should care about that. And so also, can you see that you can see also if I just have this line in my code, right? This means that A is equal to B. And if I change one position in the matrix, right? For example, this matrix to 3, and also the corresponding position in the second matrix also change. So this is so weird, but if you don't want to do that, you should put a copy function here and then make a copy of the matrix. And this means that we have another memory for the B separated, another separated memory for the B, not the same memory for the B. And then we change the value in the A, and then we print that. So if I just print that, you can see the position is not 3. And I will make sure that the first, these two matrices are different. So as a summary, this is a good way to create a copy of the matrix and then do some operation on that and change the value that you have in that matrix before doing that to make sure that you have the original one. And so that's it. And for this video, I just want to mention that this is important in the Python programming. And for the second part of this lecture, I will talk about the loading data with Numpy. And that can be also useful for assignment 3. And let's see how we can load data in the Numpy. So loading data and loading a data set with Numpy at the first can be a little bit tricky because maybe your data have some missing value, or you won't just have one column or one column and or two columns, and how we can modify missing value in the data set. That's all that are important, and we should make sure that the data set load in an appropriate way in your program. So there are many ways to do that, but I will talk about 4 options that we have to load data in the Python that are useful, and I should mention that the first one is getting more line of the code to implement, and the fourth one just we have 2 lines, and for 2 or 3 lines to load data. But the first one is more powerful, and you can do anything that you want for your data set. But if you can load data by, for example, or 3 or 4, that would be better or easier. But generally, you should try using load text or pandas first, and then if data does not load to your data to code, then you can use the first way that we introduce here. So if your data has 3 key features, for example, missing data types, or mixed data types, or something like this, you may need to resort to one of the manual methods, which are the first or second one. So your data generally be stored in a CSV file or TSV file, and the difference between these two files are the character that we separate each column. So for example, for the first one, CSV, we use the comma, and then we separate the value that we have in each row by comma. For example, here we have a header in the file, which is length, width, and height, and then for each row we have some values, for example, 2 or 3.1 or something like this, and each value is separated by comma. And we want to load this data in our program. And for the TSV file, the value for each column is separated by tab. So let's see how we can load this data in our program. For the first option that I mentioned here, we need to use a loop over the all lines that we have, and then we need to create a list for each line and then convert it to the Numpy or anything else that we want. So for example, here we have data.csv, which is the file name that we want to load in our data. And we just create an empty list, and because we want to store every line that we have in this function to this empty list. So after that, we call the open object to open this file that we have here, and we pass the file name, and then the mode of the open file object is reading, and then we call it the raw data. And for each line in the raw data, we at the first we call a function which is a strip parentheses, and then this l.strip remove the end line for each the end line of the each line. For example, when you have a line in the file, at the end you have a character that mentioned that you should go to the next line. So we don't want this end line, and then we just remove the end line from one string that we read from file by l.strip. And then we call another function which is split, because and then we pass a character that we want to split the string line by this character. So after that, for example, here we need to read this line of the file, which is length, comma, width, and comma, and then. So so after this line, we have a list of the content of the list is length, width, and height, and then so we just need to call this function, which is a split, and then pass a character that we want to split the character that we have in the line. So the line is a list of the objects that we have in this line, and this should be an error because we don't have this indent here, and I will make sure that this is not true, but we should have this indent here because this line should be aligned with this line. And then for each line, we have another for loop here. For x in line means that here, if we read this line, we want to change each of these numbers to float, because at the first they are a string, and we want to get the value of each one. And then after that we have, for example, 2, 3.1, and 17.4, but they are a string, and we want to change them to actual value that they have. So we can call another for loop here, and we want to get the float of the x for each x in the line, which means that x is the each value that we have here. right? So after that, changing the value that we have in the line, we have another list which the value of each element is changed to float, and then we append this list to another list that we want to store the lines in the file. And then after that, we use np.array to convert this list to another matrix that we have in the Numpy, because this is the list of the list, and this means that we are converting this list of the list to a two-dimensional array as an output. So this approach gives the most control, but is the most involved, because in most cases we want to at the first we need to remove the line and then split the line by comma characters, and then we have a string in the list and we want to change it to float, and then as you can see, all the operation that we need to do for the file are doing by ourselves, and this can give the most control, and you can change it to anything that you want. For example, for a line, you can change something here. For example, if you don't have a value for a line, you can ignore that line, and then this can give us a control to our coding. So as I mentioned, also note that we shouldn't have an indent here. I will make sure that this be correct before releasing the slides. So also this is another way to show for loops in the Python. At the first, we get the output, and then we mention for x in a line. And because the line is a list, for each element that we have in this list, we get the output like this. So let me show an example of this in here. For example, I have a string which is 2.0, 3.5, and 1.2, right? This is a string, and I get this line from a file, and I want to store this line in another list. For example, here, I want to store this line in another empty list as an output, which can be a list of all lines that we have in the file, right? So at the first, I need to get a list of elements that I have in this string. I will call a dot split, and I mention that I pass a character that I want to use as a separation between element that I have in the list. And I just call list of elements to see the output. So here you can see I had a string and I just call split and then pass comma. And then I get a list of all elements that I have separated by comma. The first I have 2 point, and also as I mentioned, all of these elements are string because they have quotation. And if I want to change the value of these, if I want to convert each element from a string to float numbers or something like this, I can have another list, which is float list elements, for example, and I have another list which get float x, and then for x in list element. So this means that for each element that we have in this list, I want to get a float x of that element. So after that, I just print float list element here. I run it. So you can see the difference. Then the first, this is the list element, and this is the float list element. So in the first list, we have a list of string. And in the second one, we just convert each element to float value, right? So this is all we need to do for getting lines in the file, and then as output, we have data. So for the second one, option 2 that we have, let's see what was the second one. The second one is use Python CVS module to create a list and convert it. So for the option 2, we need to use Python CSV module. And then, as I mentioned, if you want to use a module, you need to import that before using that. So at the first line, we need to import CSV file, CSV module. And then same as option 1, we need to have a file name. And then we have also same as option 1, we need to have another open object and then pass the file name and pass the mode, which is the reading. And instead of doing a for loop like this here, we just need to call a function from this module, which is reader. And we just need to call it csv.reader and then pass the file that we have here, raw data, and we need to pass a character that we need to as a delimiter, and then this function can do all that did we here by ourselves, and then after that we need to convert the output of this function to the list by calling list parentheses and the name of the output that we have here. And then after that, if we just want to convert to the Numpy array or matrix in the Numpy, we just need to pass this to another function that we have in the Numpy, which is numpy.array. So if you want to change this argument here by tab, you need to use this, which is the character that we use for the tab separator. So as you can see, this is more easier to read the file by this module, but you cannot change the for example, one line, or you cannot if you have some missing value in one line or two line, that would be hard to deal with that in this approach. because here you have a for loop and you can do anything that you want for each line. But here we just pass the data to the function for the CSV, and that would be hard to dealing with missing value here. But if you don't have the missing value in the file, that would be more easier to use just this function from this module. So another approach that we can use for the loading data with Numpy would be using Numpy load text function, load text function. And here you can see by just calling 3 lines and just coding 3 lines, you can read the file as an option 2, and option 1, you can have file name here, and then also create another object for the open and then pass the file name. But instead of using CSV file, CSV module here, you need to call np.loadText and then pass the raw data and the same character that we use here, which is comma. And then we get just the output. We don't need to convert it to the np.array because the np.loadText already returns an Numpy array for you. After that, you have all the data here in this variable. So another option that we can use for the loading data here is use pandas to create a data frame. And pandas as a Numpy is a powerful module or sub-function that can be used in the data science. And for example, if you want to use pandas, you can import that as a PD, which is another name that we choose here to use pandas, and then you have a file name, and then there is a function in the pandas which is read CSV and then passing file name and the character that you want to use as separate column, and this can give us a data frame, and then for the data frame you just need to call to Numpy to create a Numpy array from your data, which is optional, but that would be better because in most cases you want to do some operation on your data with Numpy, and then if you have a data in the Numpy array, that would be better. So these are 4 ways that we can load data in the Python. I want to talk about a little more about the pandas. Pandas is a library for data manipulation in the Python, and this is a so useful and popular library in the Python, especially for working with data, and most data science are using pandas to work with the data that they are working on that. So if you want to import that, you just need to add this line to your code, and such as Numpy, import pandas as a PD. And let's see some example in the pandas, but I will not talk about too much about the pandas, but that would be a good introduction for the pandas. If you are interested, you can find some more resources for that in the web, but the core of the pandas is the data frame, such as Numpy that we have array. Here in the pandas, we have data frame. This is because we want to read some data, and then data is an essential material that we have in the pandas, same as Numpy that we have array, because we want to have some version of a vectors, matrix, or something like this. So the array is essential for Numpy. Here for the pandas, we have data frame. Works similarly to table in a SQL database, and or R data frame, if you are familiar with SQL and R, and that can give you a way to access column by name and perform basic data manipulation and calculation. Also support things like joining, merging, that could be done with R programming or SQL. So as I mentioned before, if you want to read a file or a data set, you can call this function, which is read CSV, and then file name, and then you have a data frame. So if you want to assign a name for the column, each column you can assign that by calling a function, an attribute which is data.columns, and then assigning a list which is the name that you want for each column. For example, for the first one, we want to name that X, and the second one Y, and then Z. And then there are some useful function in the data frame that you can use that. For example, if you have a data set and you want to sort lines of the data set by value that you have in one column. For example, here you want to sort the values that you have by column X. So here you just need call a function sort values and then pass a parameter which is by, and assign by to the X character, and then this can give us that another data frame, or not, same data frame, that the value of the line are sorted by X. This is so easy working with data pandas, because if you want to sort the values in the data set, that would be hard, but by just by coding the one line, you can do that with the pandas. And you can have access to, as I mentioned here, you can access the column by name. If you pass X character as an index to the data frame, you can get the value that you have in one column, which called an X, and then get the summation over the all column to add another column to the data frame, which calls sum, and then get the summation of all columns that you have in the data frame. So this line can add another column to the data frame, which called sum. You can get a mean average of the all values that you have in the data frame by calling this function, which is .mean parentheses, and also you can just get two columns from data frame and then convert it to Numpy. So by calling data df square bracket X character comma Y character, you are saying that you just want two columns from your data set, and you don't care about other columns. That can happen sometimes, that you have lots of information in your data set, but you just want 2 column or 3 column. This can give opportunity to use an option to use 2 column or any number of columns that you want, and then convert it to the Numpy. So this can show that how we can work with pandas, but there's lots of resources in the web, and if you want or interested in the data science, I would suggest that could look at them and work with pandas. So this example are just a start, and if things will go wrong when you try to load your data, you need to look on the Stack Exchange or the documentation of the function, for example, because in this website, for example, Stack Exchange, you can find similar problems from other people and then find the solution, or you can find the solution also by yourself and look at the documentation or function. And if you look on the Stack Exchange, you can find same message error that other people got, and then see how they deal with this error. And also there are other arguments that we can use in the function. For example, here we have a function for the pandas which is read CSV. But if you look at the documentation of the function, you can see other optional arguments that you can pass to the function, and that also might be helpful for example, you want to deal with empty values in the special way. How you can do that? You might find the useful argument for the function, that you change the value of the argument to deal with for example, empty values or something like this. So in most cases, that would be useful to look at the documentation of the function for optional function argument. And for example, if your file doesn't have a header, that would be also useful to see in the optional function argument to deal with the missing header. And I mean the header in the file is this line, which is the name of the column that we have in the file. So sometimes you have that, but sometimes you don't have in the file. So how the function can deal with this situation if you have or if you don't have them. For example, here we named each column by ourselves to X, Y, Z. But if we have a header for the file, we don't want to do that because we already have that. So this is all I want to talk about the loading data. After that, you would be able to load your data with these 4 options that we have here. And in the next topic, I want to talk about a kind of different topic that we are talking in this lecture, which is a computational complexity. And you might be familiar with that already, but we are not going in the detail of this. but if you know about this, it can help you to code in the Python more effectively. So we know we want to talk about vector and matrix operation and then amount of time they take, because if you, for example, if you have two matrices and you want to have a multiplication between them, we want to know how much, how the amount of time this operation can take, because that would be so tricky if the number of rows or the dimension of the matrix is large, and for example 1 million by 1 million numbers that you have in the matrix. So in this case, the multiplication between two matrices is so tricky, and that can take a lot of time, or if you can do it with some more complicated algorithm, that can take much less time. So the advantage of the Numpy that if we use Numpy for the matrix and the vector, the advantage of the Numpy is that the Numpy has optimized a lot of these, so they can less time. They take less time. And but we need to have a formal language for discussing the speed of an algorithm, because we have an algorithm and we have another algorithm. So we want to talk about how much time this algorithm takes, and compare the value of that we have for the first one with another one. So if we want to do that, we need to have a formal language for the complexity of the algorithm. So the mathematical language used by computer science and the mathematician is called complexity. So there is a high-level idea for this topic, which is the complexity of an algorithm is the number of basic operations used by the algorithm as a function of the input size. So if we want to talk about the complexity of an algorithm, we need to talk about the number of basic operations that we have in that algorithm. So what are basic operations? The basic operation is any computation that has a constant runtime as a function of input size. So we can think about basic operation as a building block of algorithm. So example that we can have for the basic operation are, for example, adding, subtracting, or something like this, arithmetic operation, basic function that we have. So the most simple basic operation that I have in my mind is adding two values or variables. So this is a basic operation, and we want to count the number of basic operations that we have in the algorithm as a complexity of that. So let's see an example, and this is the array scanning, and then we want to find the maximum value that we have in the list of numbers. So we have a list of numbers, and for example, the grade of student, and we want to find the maximum value that we have in the list. So we define a function here, which is we call max, and passing the list. and then assign a value. We assign a variable to minus infinity to which we call here m, and then we have a for loop over the list that we have here for each element that we have in the list, and we check that if the value of this element, the current element, is greater than n, which is the variable that we define here, then we call it, we assign a value for n. This means that we find another maximum value until now. So we just need to replace m by a. And in another step of the for loop, if we get another maximum, we just replace them by that value that we find, which is more larger than the maximum value that we find here. And at the end, we just need to return n as a maximum value that we find. So if you want to know what is the complexity of this algorithm, we need at the first to find the basic operation that's used in this algorithm, right? So the basic operation are this assigning operation that we have here, which is n minus infinity. And we have another assigning value in the for loop because we get an element from the A, and then assign the value of that element to A, right? So we have one basic operation here, one basic operation in the for loop, and we have a comparison here to compare the A value by n, which is another basic operation, and then assign a value for n if we find another maximum value. So we have this basic operation, and if the length of A is n, and how many basic operations will be performed by maximum value. So we have n values in the list. So these for loops can take n times, right? So for these for loops, we have n times, and for each one, we have 3 basic operations, one in the for loops, one in the if, and one in this line. So the number of operations that can be performed in the for loop are 3 times n, right? Because this can take n, and for each one, we have 3 basic operations. And then we have another operation here, which is out of the for loop. So the basic operation that we can perform in this algorithm are 3 times n plus 1. So if we know that the length of the A is n, the basic operation is 3 times n plus 1. So if if the contents of A change, and we have n numbers in the list, but the value of each element change or something like this. So the runtime of this algorithm for finding the maximum value does not depend on the content of the A, because we have different numbers, different values for each element. This cannot change the runtime of this algorithm, right? So we just need to have n numbers in the list, and then the basic operation that we have here are 3 times plus 1. So Uh, as I mentioned, I mentioned the basic operation here, and then we have another algorithm here. And in the previous example, maximum didn't depend on the content of the A, right? Because this doesn't change anything if we change the value of the elements in there. So this is not always the case. For example, here we have another function which is find first zero, and we pass another list to this function, and at first we assign a value for the I, which is zero, and for each element that we have in the list, we check that if the A is equal to zero, we just return the index of that element. If A is not equal to that, we just increment the indicator for the index. At the first, that was zero, and then if we cannot find the zero at the first position, we need to go to the another location, which is the one, and this can happen until the end of the list. So if we didn't find the zero in the list, we just need to return none. So here, what are the basic operation that we use in this algorithm? We have a basic operation here, which is I equal to zero, and we have the basic operation in the for loop, which is assigning the value from list to the A, and then we check we have another basic operation here, which is assigning A to zero, and then we have a basic operation here, which is increment the value of the A by one. So these are the basic operations in this algorithm. If A has length n, how many basic operations will we perform based on find first zero? So we have a for loop here, and consider that the first position in the list is zero. This means that at the first try in the for loop, we can find the zero and then return the index, and then this is the end of the for loop. So it's completely dependent on the content of the A here to find the basic operation, the number of basic operation here. For example, in the base case, we have one step for the loop, for the for loop, and for the worst case, we have we don't have zero in the list, and we just need to check all the elements that we have in the list, right? If we don't have a zero in the list, you need to go over all the elements in the list to find an index that the value of that position is zero. So this means that it's the content of the A is so important in this algorithm, but here the content of A doesn't matter because for any list that you pass to this function, we need to go over all the members in the list. But here, because return is in the if we have just 1 0 at the first position, we need to go over the loops, but at the first step we find the zero and we go out of the for loop and then the function finished. But if we cannot find the zero and we don't have a zero in the list, this means that we should go over all the elements that we have in the list, which means that this takes n times. So it's a standard practice to assume the worst possible content of the A. This means that we need to, if we want to talk about the complexity of this algorithm, we need to talk about the worst case analysis, which means that this algorithm uh, at the worst case take n step for the for loops. So this also can help you to understand that the number of times that for loops take in your algorithm or something like this. And if they in computer scientists have a formal notation for discussing the runtime of the algorithm as a function of the algorithm input size, which we call it big O notation. So this is a formal definition of the big O notation. You want to you don't want to you don't need to memorize this definition of the big O notation, but if you see some example of the big O notation, that I think that would be useful for coding in the Python. So let's read the definition of the big O notation, which is let f and g be function, then big O notation of the g(x) is equal to fx, and if and only if there exists a constant m and exists x0 such that the absolute value of the x is less than m at the times absolute value of g8 for all x greater than x0. This means that for a large number, intuitively gx is always greater than fx up to a constant. It means that we can find upper bound for the gx for the fx. So this means that if you can find a number for a large number, gx always is greater than fx, and this can help to formulate the notation that we have for comparing two algorithms. For example, here we have two functions, fx, which is 10 times x, and gx is x squared. And then, for example, after 10, the value of 10, you can see gx is always greater than the fx. And this means that here, fx is the big O notation of gx, which means that fx is the 10x, and 10x is equal to big O notation of x squared. This is kind of complicated if you didn't see this notation before, but don't worry about that. I just want to mention that because that helps you to understand your code complexity, hopefully someday. But if you are not familiar with that, don't worry about that, because it's not the main concept in this course. An algorithm's complexity is a measure of its runtime and as a function of input size, ignoring the constant factor. For example, here we have a plus one here, which is as a basic comparison, but we don't care about that. Also, we don't care about the number of basic operation that we have here. We just want to know that this algorithm is uh, the runtime of this algorithm is big O notation of n, because we have a for loop here, and the for loop can take n steps. It's typical to consider the worst case input size of input, the worst case input of the big size, and then big O notation is used to formalize this concept, so the algorithm can be compared to each other based on the big O notation. And let's talk about a little more about the numerical linear algebra, and then numerical linear algebra is the study of efficient algorithm for performing a linear algebra computation. So linear algebra are the core of many algorithms that we want to do with our data. For example, in the matrix multiplication and inversion, you need to know the linear algebra. And for example, in the page rank, that is the main algorithm that is used by Google at the first. They used eigenvalues and calculate that. So this is so important to use this algorithm based on linear algebra efficiently. And also many of recommendation systems like Netflix, Amazon, Google Ads are based on the matrix decomposition. And this means that the linear algebra is a core of many algorithms, and for example, for the first operation, the basic operation that we can discuss, element-wise operation. And then, as an example, what is the complexity of multiplying n times n matrix by a scalar? So, for example, here, this is not the syntax for the Python. It's just a pseudo code for showing some example in the linear algebra. So if we have an input, which is the A, which is a n times n matrix, and we won't have an output, which is another matrix, right? For each element that we have in this matrix, two-dimensional matrix, we need to get the value of the gap position and then multiply that by a constant or scalar. For example, here alpha. So we need to have two for loops, one for the rows and one for the columns. And then we get that position, which we can do by this, and then multiply that position, the value of that position by alpha, and then assign it to another matrix. And here we can do that by two for loop, right? So this means that the complexity of this algorithm cannot go up, cannot pass n squared. Because we have two for loops, and for each, for example, for each row, we have n columns that we want to access. So the complexity of this algorithm is big O notation, big O of n squared, right? So what about matrix addition? We have two matrix and we want to add element wise down and then we have another matrix which is C here. We get the A and B and then we have two for loop, one for the rows and one for columns, and we access each position and then get the value of that and then assign it, then add the two values for two position and then assigning this to C matrix. Also, this also because we have two for loops here, the complexity of this algorithm also should be n squared for 2n times n matrix. And these are linear algebra operation that we are talking about that, and then finding the complexity of this linear algebra, because as I mentioned here, these linear algebra are the core of many algorithms. So we should care about them because we want to have some algorithms that are efficient and then use them for doing these tasks that we have in the real life. So a useful skill for evaluating numerical algorithm is translation between sum product and loops. So consider that we want to take an inner product of two vectors with length n. So we have a vector with the length a, and we have another vector which is exactly same length. So we want to compute the inner product of these two, and for example, in the linear algebra, you can transpose x and then multiply that by another vector, which is a summation over xi, which is the I position in the x, and then corresponding position in the y. So how we can do that in the Python? So we get the x and y as and a y, and then as an input, and then we have the output, which is out. The first out is 0, and we have one for loop from n from from 1 until n, and then we get the index I from x, and then index I from y, and then multiply that, and then adding them all together as output. So a single sum or product can often be translated directly to a loop. This means that the inner product of the two lengths and vectors can have a complexity of big O n. Because we have just one for loop, this algorithm can take n times, right? Cannot have more than n times, right? So another operation that we have in the linear algebra is outer products, and the outer product does not have sums, and instead of that, the output is the n by n matrix. Here we just have one single value as output, but we have here as output is we have n times n matrix. So we have, for example, here x and y, and we get the as output we want to have for the aij, we get the first in the I index in the x, and then j index in the y, and multiply that, and then as output we have that value for a, I, and ij. So to do that with the Python, we need to have a for loop for the going to the all in index that we have in the first array, and we have another for loops in the for the y values that we have, and then we assign the value for the matrix A by multiplication of two elements that we have in the x and y. So this can show that also we have two for loops. So the complexity of these algorithms is n to a square, n a square. And also for the we just have here we just have two vectors, and the output is the matrix. And if we have two matrix and we want to compute the matrix multiplication, we can decompose this problem to a bunch of vector products. And then, for example, here we let A and B be n by n matrices, and then we just want to compute another matrix, which is the matrix multiplication. So so we need to get a first row, for example, from A, and then multiply that each element in the first row of the A to a column from the B, right, in the matrix multiplication. So if we want to, and then after that we have a summation over that to find just one position in the output matrix. So for example, here we have a for loop for the all rows that we have in the A, and for each one of the rows we need to have another for loops to get columns in the second matrix, and then we need to have another for loop to compute this formula, because A can be from 1 to 1, 1 to n, sorry, I here can be from 1 to n. J also is another index that we use here as a column in the second matrix, can be from 1 to n. And also for each one, the k can be also from 1 to n also. Then we have a summation over that. So it's obvious that we need to have another for loop for the k for each I and j value here to compute this formula. So as you can see, the naive method for the matrix multiplication has a complexity of O n cube, and because we have three for loops into and each for is in another for. For example, here you can for the first step I is equal to 1, but for the I is equal to 1 we need to go through the j from 1 to n, and then k from 1 to n. This means that the complexity of this algorithm is n cube. So this is all I want to talk about in this lecture, and this is the end. And today we talk about an important mistake in the Python that we need to care about that in the coding, that we just need to use the copy instead of just assigning two metrics or something and get a view of that. And I would suggest that mostly use the copy function in the Numpy. And then we show four options for loading data. And then we talk about a little bit about the pandas that can be useful for data sciences. And we just introduced some notation for the computational complexity to show that how we can compute the runtime of the one algorithm. We show a definition of the big O notation, but that doesn't matter. But that would be good to have some experience on this definition, especially for computer science student. And also we show that how we can compute computational complex I mean the computational complexity of this algorithm in the linear algebra, because they are so important in the many algorithms that we want to implement, and they are core of many algorithms. So if you have any question about this lecture or the assignment, just come to office hour and demo session, and then, or you can send an email or post on the platform. So by now, and take care.